Welcome to the app Sum and Difference with 2 Dice. This app helps explore fundamental concepts in probability. In the app, we'll throw 1 or 2 dice and explore the connection between the results obtained and the theoretical results we could expect. Let's start with 1 die. The die is symmetrical, and so the probability for each of the results is the same. So it is a sixth. There's no reason to expect, for example, that 4 will turn out more times than, say, 1. Let's click the dice, and we got 3. The leading result will be colored in red. Let's click again, and we have 2. Though the probabilities are equal, we actually don't expect to get each result once before another gets a second roll. That would actually be a rare occurrence. Let's click again, and again, and so 4 is now in the lead. We will do a race to 80. Once we click the button, the dice will be rolled again and again until one of the numbers is rolled 80 times first, and there will be one winner. What we don't expect to happen is that one number, say 5, reaches 80 while a different number is only at 20. Let's do the race and pause. 4 is in the lead. Here, 2 and 4 are tied. It's as if there's a competition between 2 and 4. Let's see if one of them wins. And 2 is in a big lead. And 2 wins. In second place, we have 6, then 3, then 5, and 4 is in fifth place. We can see the differences between the results are fairly small with the race to 80. It could happen that the last place will reach only about 40, half of the winner. But if we had a race until 1 million, we expect the distribution to even out, so both first place and last place will appear not much more or less than a sixth of the total number of rolls. Let's reset and do one more race. So 3 is in the lead. 1 and 3 are in competition. 4 appeared for a second as a winner. At this point, it seems that 4 or 3 will be the winners. And let's see. And it's 3. 4 doesn't seem to be lucky today. Now, we move to addition mode. The possible sums now range between 2 and 12. Some students may expect an equal distribution here as well, but this time, as you know, 7 has an advantage. There are many sums that give 7, 1 and 6, 2 and 5, and so on, whereas 2 is obtained only by the throw of 1 and 12 only by the throw of 6 and 6, so they're expected to lag behind. Let's click the dice. And we got 5. Let's click again. 4. Again 4. 6. Okay. Now, let's do a race to 80, and we'll try to stop when a new number takes the lead. Okay, so here 6 and 7 are tied. Let's continue. Oh, the number 8 even had its moment. And we see the expected pattern beginning to form. The reason for this pattern will be clear when we move to theoretical mode. Let's continue. And now 7 is in the lead, and the triangular pattern becomes even more apparent. We continue. And continue. And 7 won. 2 and 12, as expected, are in last place. And the closer the number is to 7, the more results it tends to get. Let's do it again. We'll click Reset and Race to 80. Here we see 9 is in the lead. We continue. Now 5 and 6 are tied. 5 to 9 are unexpectedly uniform. We continue. Now 7 is in the lead. And we have the final result. We have an interesting variation from the relative probabilities of each result. 9, for example, surpassed 8. But this is to be expected with a still relatively small number of dice rolls. Let's do the race one more time. 6 is leading. 9, 6. And the final result is reached. Now, let's move to theoretical mode. Here we see all 36 passable dice throws. Now the question is, what throws correspond to each result? We can click this throw. We see it marked in red. We click again, and it moves to its place. We can do the same for 12. To get the sum 11, the dice have to give 5 and 6, but this result appears twice. To emphasize this, we used 2 dice with different colors. Here, the white die gives 6 and the black die gives 5. And here is the opposite. We can bring these throws to their place by also clicking the sum. Now we'll bring the throws that give 3. And how many throws give 7? This is a question you can pose to the class. After the answer, you can click, and we can see the 6 results. One has to remember to count 1 and 6 and 1 as 2 different throws. Now, let's click 6 and 5 and 4. Let's click All to Place to get the theoretical pattern. Now we can click Show Past Results. The app remembers the results obtained and shows them here. And we see this matches the theoretical pattern. Here, 5 and 9 were obtained a little more than expected, and the next pattern again corresponds very nicely to the theoretical distribution. The more throws, the closer the pattern is expected to match the theoretical distribution. In the class discussion, you can talk about the actual numerical probabilities. There are 36 rows, so the probability to get 2 with only 1 throw is 1 out of 36. 7 is obtained by 6 out of 36 throws. And 6 out of 36 is a 6th. Now, this discussion is in your hands. You could stop the lesson here or continue to examine the difference between 2 dice. So let's leave theoretical mode to subtraction. And here we can challenge the students to apply what they learned to this situation. Here we click the dice. What counts as the result now is the difference between the 2 dice. You can ask the students what number they think will win in a race to 80. Now, a common mistake students make is to think that 0 will win. A 0 is obtained by the throws 1 and 1, 2 and 2, and so on. That's 6 throws. Whereas 1, they might think, is obtained by 1 and 2, 2 and 3, 3, 4, 4, 5, and 5, 6. Together, 5 throws. The mistake is to forget that the throw 4, 5 is different than the throw 5, 4. So there are not just 5 throws that get the result of 1, but 10. Let's do the race here. We stop and see that 1 is in the lead. We continue, and we see the lead is fairly dramatic. Let's reset and do it again. 1 is continuously in the lead, and we get a nice pattern. Now, let's move to theoretical. In the course of the class discussion, see how many throws give each result. You can also ask the students to figure it out on their own before this discussion. But let's see. 6 throws give 0. 10 throws give 1. 8 throws give 2. 3 has 6 throws, and we see here that 3 and 0 have the same probability. 4 with 4, and 5 with 2 throws. Let's show the past results here, and the pattern is similar to the theoretical distribution. And the next result. That's it. We hope you enjoy this app in class. Thank you for watching.